Athina, did you?
I didn't sign anything.
Okay, so can you please fill in and sign this one? Just 2 minutes before starting. I would like, the speakers are all here, I think. Right? We have Athina, Keiran, Dursun, and José, right? I would like to inform you that we will be very strict with timing because there is the plenary at 3:30. I would like to allow you for having at least 10 minutes, 15 minutes of a break. So we will have 15 minutes per speaker, including the questions. Okay, so. And we will have, okay, this is a bit, but in this case we will have 15 minutes of contingency before 3:15.
Can you indicate like 3 minutes?
Yes, of course, yes, I will indicate 3 minutes before the
Yeah. So we have 15 minutes.
15 minutes, yes. Yeah. So I propose we start with José. Welcome everybody to this session on multidisciplinary infrastructures. I am Maria Teresa Borzacchiello from the Joint Research Center, and I give the floor to the first speaker, José Gómez Castaño, who is speaking about applying Inspire to quantify the cost of restrictions in road and rail infrastructure using time-space analysis. Please, José.
Okay.
Yep. Do you have a PDF?
Yes.
Or a PowerPoint? Can you add, please? Ah, it's a PDF, okay.
I see.
So you did it.
No problemas. Sí, ahí ahora oí. Es que cambia el modo de escritorio cuando pasas de PowerPoint a PDF. Esa cosa de estas horas. Es un PDF, ¿no? Sí, pues. Extended, tiene que estar en color.
Maybe, José, you want to say something about yourself while the technician is solving the problem?
Thank you, everybody. Good afternoon. Thank you for attending our presentation about. We are going to talk about railways and how speed restrictions and other restrictions to the infrastructure can apply to the railways and vehicles where are driving over the roads and restrict their speed and can influence to the cost where the infrastructure managers and railway undertakers have to pay when you use the infrastructure. Well, this is the index and start. Which is the goal? The goal is to develop a procedure to compute detailed impact of different events on railways and road capacity using Inspire and other interoperable models. Here you can see an example of the Spanish Railways network. It has around two kinds of gauge, an UEC gauge and a national gauge. And we can define capacity in two models. Capacity is a measure of the ability to move a specific amount of traffic over a defined rail line with a given set of resources and a specific service plan. This is a classical definition. But now we can introduce, and UIC can introduce another definition based on the scope of the traffic. So the capacity of any railway infrastructure can be defined at, based on the total number of possible paths in a defined time, considering the actual path mix or known developments, respectively to the infrastructure manager's own assumptions in nodes, individual lines, or parts of the network, and also with market-oriented quality. We can find different types of capacity: theoretical capacity, practical capacity, used capacity, and available capacity, which is our interest. You can see here how an infrastructure manager can manage the infrastructures using different kinds of signals to regulate the trains on the railway lines. There are many factors to take into account to compute the capacity: number of vehicles or trains, train qualification, timetables of the trains, speed restriction length, speed restriction types, and speed restriction scheduling. Here you can find, you can see a typical type of restriction based on weather and its impact over the capacity. Different kinds of weather around Europe can influence the different trains and railway lines. So we have a problem. When a speed restriction is applied to the infrastructure, the schedule of trains is affected. Actual impact based on alphanumeric and relational database. It has a difficult computing in real time, complex offline software, and no possibility to take into account geospatial attributes. You can see here one of the timetables on the left of high speed here in Spain, and on the right, some kinds of speed restrictions in different points of the railway infrastructure. We have used to solve the problem different tools based on geospatial environment: PostGIS, GDAL, Python, QGIS, a lift-left framework to see or to represent the results, GeoServer, and OGC WMTS server. The solution is based on kinematics of the vehicles, taking into account its movement along the way. The time due to the restriction on the infrastructures affect directly to the time employed by the trains to pass through the restrictions, and the type of the vehicles also affect the different time. Here you can see the equation that relates these parameters. We can take into account also the type of trains and the length of any of the different trains. You can see different kinds of trains here in Spain. And for every time, we have assumed different wait time to ponderate these measures. Which kind of topology have we used? We use one kind of topology based on UIC topology. You can see here double track line of section, single track line of section, interlocking station, different. But it has the problem that it's a topological model and not a geometric model. So we can use Inspire to solve the problem of different change of height, change of direction of the geometry. These are the features that define the Annex 1 transport network that define Inspire. In Spain, we have translated different kind of elements as estación, bifurcación, línea, área, tramo, etc., to Inspire features as railway node, railway line, etc. So we can define different features from location features, railway node, link features as railway link, line features as railway line, and we have defined another feature that we have named as path feature translated into a train railway line. We have defined 3,594 different train rail line links for a day, and which contain this everyone. Everyone is the representation, a 3D model where X and Y is the longitude and latitude for every point of the path of the train, and Z represent the time of the schedule. So we can, we can make different geospatial analysis between different trains and the geometry of every infrastructure restriction. Which is the method? The method is as follows. We create railway link features for every pair of transport node from IGN in a PostGIS database, create train railway line features for every path from its schedule, a three-dimensional element, define a polygon feature with the interest area as incid geom, which is the geometry of the railway restriction, and aspect the restriction is defined as a line string. So we can compute in real time intersection between train real links with the incid geom, all the 3,000 trains. As a result, a set of train railway links is obtained which are affected with this restriction, everyone with its rain information. As a result, we have an example here. This is an incident between Villarrubia de Córdoba and El Higuerón, 2 points in the high-speed railway line, blue railway link, and red incident feature.
Okay. Sorry, is this real time, this information?
Yeah.
Okay.
The information is computed in real time from a schedule for scheduled trains. And if you have another special train, you can compute a new geometry from the schedule, generate a geospatial feature, put into the system, and compute, as you will see now, all the trains of if this train will be affected with a restriction. This is a geometry of 2 restrictions, as you can see. And now we can compute this impact into the trains. Over the 3,000 trains, we computed 92 affected trains, as you can see here in the blue ones. What? This is the incident zone. You can see here where trains are affected or not. Blue ones are affected by the E restriction.
Be careful.
And this one is not affected.
Affected.
And we can get all the information of these trains, computing the intersection between alphanumeric and geometric information, as you can see in the resulting application. Above you can see all the train numbers where are affected, and below the train selected geometry and where the speed restriction or restriction in capacity is produced. Conclusion, lost time is difference between real time and schedule one. Here in expression, Ri is infrastructure restriction, and T, time needed to pass through total cost for every restriction in the infrastructure is computed as a sum of all of them.
Yes.
The benefits of this methodology is more accurate results than now compute in real time all the geometries and interaction with trains and speed restrictions, take into account restriction from real geometry, geometry level accuracy instead of section of line, which is less accuracy, detailed cost for every restriction and for each train, and allows to make a decision on, by an infrastructure administrator more accurately. Better security, and overall, we can use this data with a more interoperable methodology with all organizations and methods around Europe. And thank you very much for your attention.
Thank you very much, José, for this interesting presentation and for keeping the time. I would like to ask if there are questions from the floor. Yes, over there, and Dominique.
Open source and accessible to us to be able to play with ourselves?
Now the methodology is open and is applying here in Spain in some test laboratory using data from ADIF and Fundación de los Ferrocarriles Españoles, but it's not published then. Yet is not published. But if you want to play with the methodology, we can provide you with one example. Here in Spain and in another railway lines, there is a problem with kilometric points. And before you use the geometry and a section of line, etc., you have to make a correction on the difference between theoretical kilometric points and real, but you can use in any way.
Thank you.
Thank you. And there is Dominique, the third row.
In InSpy model, there is a possibility to have the speed limit as linear referencing, but I understood that you prefer...
I don't hear you.
Oh, sorry. In InSpy model, there is a possibility to use linear referencing for the speed limit, for instance, in the road transport. But you have preferred to have the true geometry.
It is possible to apply the system to another kind of transports. You can use a baseline as a road network, as an example. You can apply this treatment on special vehicles or dangerous vehicle, as an example. You just only have to use geometry and features of roads. Here in Spain, you can use IGN geometries, and they publish now all the information in Inspire model, and then you can use all the movements of drives, motorcycles, or other kind of vehicles to test the influence of any kind of restriction.
Thank you. This is very interesting. And there is also, I think, another question. No? Okay. Thank you very much. José, I have actually one question. Is this infrastructure on the whole of the Spain, or you have only a pilot on a separate part of the... Sorry. Do you have this system on the whole of Spain, on the whole Spain, or only on some parts? Yeah.
It's based on geometries published by IGN.
Yes.
And the railway lines are across all Spain, not only this high speed, also in all the infrastructure.
So this is a system available for all the, or even the local lines?
Yes,
right?
okay.
And do you then communicate the restriction and the loss of time to the users that are in the trains in some way?
You can use the solve line. The
Yeah.
solve line also translated into the inspired schema. The solve lines in the RINF, in example, in RINF schema are only as topological information, and we translated this solve of line into that geometry. And it's also possible to use the schema and extend it to all the Europe. And you can use, for example, to analyze the influence to a restriction in Pyrenees, in example, for a TGV from Paris to Barcelona.
Okay. No, that's very interesting. Thank you very much.
Okay.
Thank you. And now I give the floor to Athina, Trakas, speaking about smart cities for a resilient future.
Good afternoon, everyone. My name is Athina Trakas. I have a question. Who of you attended the workshop on passion and commitment, the key elements to make your presentation matter? One person, two people? So bear with me, I try to implement some of the stuff in my presentation. I hope it works out. So, full screen mode. So, yeah, we all didn't have coffee. I didn't have coffee too, but I hope you're fit. You're looking forward to the break. Yeah, as said, my name is Athina Trakas. I work for the OGC, the Open Geospatial Consortium, and I'm replacing somehow my colleague Bart de Lathouwer because I will talk about the OGC Future City Pilot, and he is the initiative lead of that, but unfortunately he couldn't come to the event. So I give a short insight in what we are doing in this Future City Pilot. And so I learned I have to say why I am standing here. So we are doing that because we identified, we are from the GIS and the geospatial world, but in OGC we also partner with Building Smart Alliance, and this is the BIM world, the Building Information Model world, and there is a gap between those two worlds. And we wanted to identify what is the gap and then also try to bridge the gap. So I will later show you some scenarios where we are trying to address this. But let me go a few steps back. We are seeing globally the growth of cities. There's construction going on everywhere, not only, you know, if you remember, if you have been to Berlin in the last couple of years, you'll see a lot of cranes. But this is a global aspect. And here is also two maps of the metro in Delhi, and you can see in the last 10 years how the lines have grown. Megacities, very hot topic. We know all about that big cities are growing bigger. You know, cities with 16 million people, inhabitants, for me this is always, I don't know how logistically this works, that everyone can go to the supermarket and can buy daily food there. But these are challenges we have to face, especially also when you combine this with climate change. And this is a picture of the Climate Change Vulnerability Index, and you can see there is a correlation between the big cities, the mega cities that are growing in, not only in Asia, and the vulnerability. Today, 60 to 80% of the GDP is generated in big cities, and 70% of the global energy is consumed in cities. And by 2050, and this is just one number, 70% of the world's population will live in cities. So we can say that cities are a hotspot of the global economy and societal challenges. And I think we have only a slight idea what will come in future, and I think we should be better prepared about what is coming. The bigger the city, the more you have from everything. Culture, markets, education, creativity, that's the nice thing. People come together, they work together, innovation. But there's also kind of a downside of this. increased transportation, and without stepping too close to some people, I think we really lack of intelligent public transport systems. It doesn't help, and that's my personal opinion, it doesn't help to build new streets, but we have to rethink and come up with new concepts. But there is increased pollution, housing shortcoming, and crime, diseases, water management, water shortages not managed here. So there is positive sides, but there are also negative effects that we have to consider and take into account because we have to deal with those aspects. So smart cities can utilize ICT to increase quality of life for the inhabitants while providing sustainable development. We all talk about smart city, that's cool. Everyone has an idea what a smart city is, but how can you fill this with life? How does it look in pilot projects, for example? And how does ICT really help? And the idea is that ICT is the bricks and the mortar, so bringing the aspects together. So we have human, natural, and physical systems. They interact in space and in time. And digital systems in cities, they are becoming increasingly diverse and numerous. So cities need an open, vendor-neutral standards platform for communicating spatial and temporal data. And don't think only about the city, think about yourself as part of the city. We have all the smartphones. Imagine what nice things you can do. We had this week couple of sessions on VGI or citizen science. Just imagine your smartphone has a sensor that could sense CO2, and every 2 minutes the data is uploaded to a map, and then an intelligent city could say, or the transport network could say, okay, we have an increased CO2 index in this area of the city, so we better cut the traffic in this area, and then it's getting interesting if you cut transportation or traffic in an area. Good. So that's a few words before I start to look into the future city pilots. As I mentioned, we identified the gaps between the geospatial world and the building world, BIM, Building Information Model world. They are looking on construction, on buildings, and we see the bigger picture without looking into detail, but we need both if you want to address smart cities. So the OTC Future City pilots demonstrate how the use of open data sets coming, e.g., for example, from Inspire, from CityGML data, or IFC data, can provide stakeholders with information, knowledge, and detailed insight to consider for improved decision-making. IFC, that's the industry foundation classes, and that's the format, it's a open data format from the building world. So in GIS, geospatial world, we have CityGML as a format, and in the BIM world, they're using IFC classes. So the Future City pilot is a part of the activity of the OGC interoperability program, and there we are bringing together real-world scenarios, users, government agencies, and let them plug and play. So we take the data, we take software, we take the standards, and see how they fit together, where are the gaps, where do we need to improve software, or where's the gap in the standard. And so the Future City pilot is looking at that from a city perspective. We have identified, so we have the human systems, natural systems, and physical infrastructure, and somehow we need to use these, well, the intelligence that is in all these areas, and open spatial IT standards are a critical requirement to understand and manage relationships among these systems. And one thing was identified, there is a loss of information in the build workflow. We come from a cadastral world, from this, we have this, but if you enter the build environment, there is a loss. And that's a problem, but you could also see it as an opportunity to bring together CityGML, again, which is the geospatial world, and the BIM world with the IFC formats. And what we are doing, we pilot the interoperability arrangements. As I mentioned, geospatial, civil engineering, and BIM come perfectly together in the urban environment and are destined to work together. And we are looking into that in the Future City pilot. We have some sponsors, some visionary sponsors, and I want to name Ordnance Survey Great Britain, who was in the initiator of this pilot, Sant Cugat de Vallès in Barcelona, it's part of Barcelona, the Institut National d'Information Géographique et Forestière, IG in France, and Virtual City Systems, that's a company from Berlin. Additionally, we have 3 participants, that's the Technical University of Munich, the University of Melbourne, and Remote Sensing Services. Some of the cities provided data, then as you see a software company, and they are working together. So we have various scenarios, and I talked with Bart, and I found it interesting because the scenarios are different. So in Greenwich, one of the scenarios plays in Greenwich, they want to reduce winter death. So I said, well, winter death? So in social housing, it seems they have a problem with humidity. So they needed isolation, because in humid buildings, especially for elderly people, diseases can be fatal. So in Greenwich, they needed to understand better the building. How is the building addressed? And so we used, or they're still using, because the pilot is still going on, CityGML model of Greenwich, and sensor reading for humidity, and linking the sensors and through an OGC SOS, Sensor Observation Service, and the city model. That allows to better understand the dynamics and the dynamic characteristics of the city model. Usually city models are very static, but with this sensing aspect, they're getting more dynamic.
3 minutes.
Another project, another scenario is from Rennes. They wanted to update the city model. For example, if a contractor, if they're adding something to a building, or a building is modified, the contractor reports this back to the city, and then they validate the data, they check it against the city rules and permitting, and then they integrate and update their city model. And again, you can see that this relates to the BIM world as well as to the GIS world. In Sant Cugat, they wanted to visualize a public city service, so how does the waste management work, parking areas. So they're using city information modeling and identified a lot of interoperability standards that are available. So there was definitely a learning process for the city in Sant Cugat. And another scenario is flooding in cities. And usually we would say, okay, you take a digital elevation model and then you model the scenario, the flooding scenario, but in the Future City pilot, we are using a city model based on CityGML. This allows you to model and visualize also flooding that goes into houses, so you have again the connection to the building.
You have 3 minutes.
Mm-hmm.
Yeah.
So in very rough, we used for the GIS data, CityGML data, we provide them through a WFS, very normal for us. This is very new for the BIM world. So we provided, or in the Future City pilot, they provided the IFC data again through a WFS. Usually, they did it through email or FTP. So for them, this was a new thing. And then the processing of the data took place in a WPS. So the data was transformed from IFC to CityGML and vice versa by using WPS. And this is really very roughly. And the interesting thing is, as said, for the BIM world, this is quite new. What we also did and are doing in the pilot is include a BIM server into an SDI that allows to see an SDI from the built environment perspective. And this sounds normal, but for a lot of, I mentioned the gap at the beginning, and so this perspective into the BIM world from the geo community and vice versa, this is something new. Timelines, the project kicked off in April, and it ends in December, and we will have 5 engineering reports on all the scenarios, so you can read the findings, the gaps, what they identified for future work. And well, if you're curious and want to learn more, check on our website, contact me, contact my colleague Bartel Lattauer, and we can also inform you when the engineering reports are available. And additionally, the presentation I will provide for downloading from the site, I will add some more slides, so you can, there's more further reading and links where you can get more information on it. Thank you very much.
Thank you very much, Athina. And are there questions from the floor? Someone? No? I am interested in how did you collect user requirements for the use cases that you mentioned? Oh, sorry. How did you collect the user requirements for the use cases that you, yeah.
As I mentioned, these are the sponsors, and the requirement comes from them. So
Okay.
Ordnance Survey works with Greenwich, so the requirements for the Greenwich scenario came through Ordnance Survey, and San Cugat, they work with their people. So
Okay.
that is the idea, that the sponsors of this initiative, they come in with their requirements.
Yeah.
So that is
Yeah, and this is
straightforward.
important because, as we said, it is essential to come from the user needs and then try to solve their problems.
Yeah, and we might think about a second iteration of the process, but of the pilot. But first, we have to finish that, and then see.
Okay, good luck. Thank you.
Good.
If there are no questions, then I continue with the third speaker, which is Dursun, Yıldırım, Bayar, on the deployment of cloud urban information system in Turkey. Thank you.
Good afternoon, ladies and gentlemen, and thank you for attendance in the last hours of the conference. So it was a tiring week, but we are still here, and thank you again. My name is Dursun Yıldırım Bayar, and I'm working at the Ministry of Environment and Urbanization in Turkey at the General Directorate of Geographical Information Systems. My presentation is about Cloud Urban Information System that we have conducted in the last 2 years. At the end of 2014, we started this project with the aim of developing a cloud-based urban information system. Cloud or urban information system comes from the approach of our smart city approach. In fact, we have a smart city concept that includes urban information system and other software involved systems inside, as well as other municipal applications and other things. So Cloud Urban Information System comes the first within this project, but other systems have been developed also. So let me say earthquake risk rapid mapping system, geological etude information system, and e-plan automation system, which makes the special plans in a procedure, and Cloud Urban Information System, which includes geospatial modules. And before starting, we had to understand, and we had a journey, long journey, before starting that project. Firstly, we had to understand that every local government shall use special data in order to make effective management in their daily urban activities. But many municipalities have problems in budget, financial resources, and as well as they have technical assistance problems and also human resources problems. These issues take the municipalities take into very hard conditions. So in about 2 weeks ago, we had a survey, we made a survey, and we were taking phone calls from some municipalities who will fill the survey. We don't have experts or we don't have experienced personnel here. So these problems are really hard to solve. But let me say, there are not all the municipalities taken into problems like that. There are very strong municipalities who manage their systems besides. These are small-scale municipalities, let me say. And we see that we have very tough issues and conflicts of interest when we start to share the data, when we put this idea to many different administrations, so they come into conflicts in standards, in protocols, etc. issues. So we have to make a deep understanding on this. And why do we need urban information system? It makes a real management system for the spatial data. It's really effective for our municipalities. In Turkey, we have 30 metropolitan municipalities, as well as 1,355 municipalities. Most of them are small-scaled, but 30 metropolitan municipalities are very big, which are most of them are nearly a population to 1 million. And as you would all know, Istanbul, for example, it has 15 million of population. So they all need special data management. And why do we need cloud at this stage? The technical answer, socio-technical, we can say, it provides us data security and system security at first. It's very cost-saving, and we can use standard data over it. And it gives high performance, it's extendable. It's one of the most important things of the cloud. And we can provide effective human resource. And by using cloud technology, we can carry the spatial data management of urban data to a national level. That's another important thing also. So when we see that cloud is very sympathetic and effective way to go on. And as we all know, cloud has an irresistible dissemination throughout all the world, not in JS, but in many applications. Cloud computing has been started to use very oftenly. And software as a service is the main approach. There are other technical ways of using, such as platform as a service or infrastructure as a service. They are also possible, but software as a service comes at the first. But making them complete is wonderful. And besides before starting this project, we had to make a methodological way to start. And in 2012, our ministry conducted a project called Determination of Urban Information Systems Standards. And after that, in this project, standard teams of urban information systems has been determined. And after that, a roadmap has been determined for developing a cloud technology in order to disseminate urban information systems by cloud technology. And after this, in 2014, as I mentioned before, cloud urban information system has been started to be conducted, and this year it has been deployed. And currently, let me state here, we have already started a new project. It's technical assistance for capacity building in horizontal sector for the implementation of INSPIRE directive. This is a European Union funded, co-funded with Turkish Republic project. So, in summary, we firstly put the standards, we determined the roadmap, and with the Cloud Urban Information System project, we produced data, we developed software, we made integration, and now starting implementation. When we come to the project, about the project methodology, let me state we had 3 municipalities as pilot and a province. They are at different scales. We made data collection, digitizing of data, digitizing of licenses, digitizing of special plans, and standardization issues of special plans, infrastructure, data collection. We had many data activities on those places. And about software development, that was another couloir. Software, firstly we had the software development kit. It was the most important thing. And we needed a cloud server software. And JS server software was also needed, and we had the application, web application software. Besides those, I'm all talking about cloud, but we also developed a desktop application software. Since some of the JS issues sometimes cannot be made over the web, so desktop application is also was also developed as an additional aspect. And we also determined a data model and called it KBS GML, Urban Information System GML in translation. It was complying with the themes that we have determined within the project of Urban Information System data teams. So it gives a model which complies with data teams of Urban Information System, and above that, the national SDI, TU, CBS we call, and plus INSPIRE. So that makes it 3 coming down to the up from the urban level to the national and regional level. I'd like to show some screenshots from the softwares we have developed. With cloud server software, we can manage nodes, roles, users, work groups, user groups, and workspaces. As I said, for JS server software can make the management of users, services, data sources, layers, styles, and restrictions. Styles was an important thing also. We developed 4 modules currently within the system. That's infrastructure module, address assessment, special development, and building license module. And at the web application software, we have a main page that we can access all modules through there. We have drawing and editing functions put in that place. In the address assessment module, we have a screenshot over here. We have also address editing functions. Municipalities can enter the address points on the web, and they can register the new buildings and register it to the national system. We have query functions, as all JS softwares have. Infrastructure module, it's also very useful for the municipalities that they can follow up their issues of drilling and etc. works. At special plan status module, it's also an important module because people, the citizens, let me say, citizens come to municipality with official letters for requesting their status, their parcel status, and it makes lots of paperwork. So this system lets them to view their status of parcel or houses from the internet. They just enter and they can see if it's open to citizens. But also it's very useful for the personnel of the municipality, that personal staff of the municipality can directly print it out when a citizen comes and just stamp it and give. So that's very useful.
You have 2 minutes left.
2 minutes?
Yes.
Thank you. I'll be fastening. Okay. Desktop application software is a complementary software. It's also very useful, and it can connect directly to the cloud to the other system. We also had challenges as all project management issues. There were scheduling problems, defining complex workflows and job processes. It's a real difficulty, as it's in almost all projects. But in municipal works, job processes are more complex. Project schedule is also another important thing. And it's also a JS issue, obtaining necessary services from third parties. It's also another problem. So this should be considered. And teamwork, it's the most important thing. Here I put my colleagues, and my department head is also here, is my chance, Mr. Birhan. So it needs a big team. I couldn't list my colleagues in the project developer team, but it really needs teamwork. Yeah, currently the system is deployed, and as I mentioned at the first, within our new project, new geospatial modules will be developed in the technical assistance project. I'll pass through it quickly as the time passes, but just to give an idea, it started in March this year and will end in March 2018. It's a comprehensive project which includes many items besides developing geospatial modules. There will be trainings and lots of other activities. And it's a capacity building project. And in conclusions, development of cloud urban information system gained big experience in both technical and organizational directions, as well as the project deliverables. And cloud urban information system in Turkey is intended to be disseminated, and preparation has been started for involving other municipalities to this system. So if you build a cloud, and it's the main aim, you can take thousands of municipalities into that cloud. And if you have more hardware, you can 1,000 more. And Inspire driving cloud-based geospatial software modules will provide more functionality and providing a maximum level of abilities of an urban information system. Thank you.
Thank you. Thank you. Do you have any question from the floor? No? Dursun, You said you will use this application in various pilot municipalities. Maybe I want to in various pilot municipalities, right? Do they use, for which kind of application they use this cloud information system? For urban planning, transport planning, e-government services? What kind of use cases did you apply?
Our pilot municipalities, as well as most of the other municipalities in our pilot scale, small scale, they use urban information system mostly for urban management activities, but firstly in numbering, address assessment, registering the addresses. That's one of the most important things. As I mentioned, the special development letter. Citizens come and request letters inquiring their status of special development. They use in that way. In transportation, in small-scale municipalities, yeah, they would. But in metropolitan municipalities, there are very good examples. Also in Turkey, they use. But in small-scale municipalities, it's not a priority, let me say. But it should be used. It would be very nice. Most of the issues are these, and also in querying, citizens query, and urban atlas, using it for the citizens. Citizens use it as an urban atlas, for taking information.
Yeah. You mentioned challenges and benefits of the implementation. Do you plan to have a structured cost-benefit analysis of the implementation of your system in the future, or in this project that you just mentioned?
The cost-benefit analysis, yeah, they were all done. They were all done through the determination of the roadmap, and before that, determination of the standards. A cloud saves you approximately 150 million euro just for the hardware, for 1,000 municipality. So it's very cost-saving, and you centralize the data, you centralize the system, and serve it as a software, as a service to many municipalities. And if it's extendable, one of the most important things, it's extendable, and you can extend it as much as you can. It's not a technical thing, as much as you can, but you can take much more municipalities if you have a stronger system.
Right, thank you very much.
Thank you.
Any question? No, so I thank you. And I give the floor to the last speaker of today, Keiran Millard. Welcome. Keiran will speak about using Inspire as part of the strategy for ubiquitous services in the Internet of Things.
Okay. So just whilst I was switching my presentation over, I just uploaded it to the wrong room. I'm Keiran Millard. Most of you might know me from working as part of the Inspire thematic clusters, but in my day job I work for British Standards. And one of the things we do in British Standards is we work with a diverse range of communities to understand what their problems are and how we can actually use and create and develop standards to help them overcome the barriers and pain barriers, which might be new areas of innovation, or to support compliance with a particular piece of legislation, for example. And one of the things we've been involved with is with the IoT area and the innovation that's happening there. So what I want to talk about is what we've been doing in the IoT space and how that fits with Inspire. And this links quite nicely, actually, with Athina's presentation earlier, because some of the standards we've been developing here have actually been used on some of the smart cities demonstrators as well. So for anybody who was at the Geospatial World Forum earlier in the year, you probably would have seen lots of slides and presentations that look like this, which painted this wonderful picture of the IoT future with everything interconnected and all these services working with one another. Now, as we've heard a lot over this coming week. You know, Inspire is being refocused slightly to focus much more on the kind of environmental reporting use case. That's a primary driver for Inspire. But working with the IoT community, I don't think we shouldn't lose sight of the benefits that Inspire can actually bring to that community. And we should be looking at Inspire as actually helping to support the IoT use case as well as just the environmental reporting use case. So when you talk to the IoT community, have they heard about OGC? No. Have they heard about ISO 1900 suite of standards? No. Have they heard about Inspire? No. Are they interested in interoperability and having lots of data services working with each other? Yes. So basically they're looking at exactly the same sort of problems that Inspire was looking at well over sort of like 5, maybe even sort of like 10 years ago. Wonderfully going forward in what they consider to be a bit of a virgin territory, and there's nothing existing there. Now, there is a lot where these two communities could actually merge and they could work much more closely together. So what we have is that Inspire provides a very rich array of both rich data models, service models, harmonized data that could actually underpin and act as a catapult going forward in the IoT space. Now, IoT is not without its standards. This is one that was actually just released this year through BSI. So this was a standard that was developed by an organization who had created the standard privately and wanted to make it more publicly available so everybody else could use it rather than reinvent it itself. So this, the Hypercat specification, it's actually a free to download standard. It's there and exists. But really, what does this standard do? Well, it's around IoT, but really all it provides is a simple catalog model to enable people to go around and expose and discover resources that are available. It's a bit like a sort of RDF, sort of like triple store, effectively, and there's some nice JSON syntax behind it that explains how it can be done. It works, and it has a lot of features in there as well. So the Hypercat community were quite excited by that introduced something called geographic search into their specification that provides a bounding box approach. Now, it becomes pretty obvious near how this starts to interlock much more closely with what's happening in the Inspire community. But it's confronted. And I'm not expecting you to read all these things, but effectively, if you were to just read one thing about this, what this really tells you is one thing. Hypercat gives you lots of breadth, but doesn't actually give you much depth. In order to get the depth, Hypercat needs to link with other services that provide richer semantics. So you've got a very thin veneer layer that does a very good job very well, but doesn't do much more once you get below the surface. So how can we address this? And in fact, this was actually something that was actually being only discussed this week at the sort of like the Hypercat meeting. Well, if we look at the use case of hydrology, and if we have time series coming from sort of like water gauges, well, there is very rich semantic models that already exist there. So you get that from the Inspire hydrology specification in terms of describing the things that you're actually monitoring. You have a rich data model that already explains about how you're doing it in the EF data specification, what you're measuring, why you measure it, how it's being done. It already exists. There's also a really rich semantic model that exists about the observation itself. So here's my thing, this is how it's being done, and these are the results of the observation process. So all those bits of the jigsaw that ideally the IoT community would like to be able to rely on, and they think don't exist, is there. You know, it's a bit of an iceberg situation where 80% of the stuff is there and exists, but what isn't happening is the joining up. Coming back to Athina's presentation, it's a bit like the BIM community discovering the GIS community. It's like, oh, you exist, we can work together. The IoT community is in a similar way, but I think getting this engagement would work really well. So if we come back to the simple model of the IoT future, in order to get the numbers into the app, the things that the citizens want to use from these lightweight sensors, we need to look at how we can capitalize on the richness of the underlying Inspire model and use that as a driver to actually take things forward. And I actually think in terms of value to citizens, enabling Inspire in this way, having Inspire exposed to allow people to build these kind of services will probably give us far more citizen benefit than just the pure environmental report case that we're looking at the moment. So in summary, what does this mean? Well, it's largely about looking at Inspire beyond environmental reporting. So yes, Water Framework Directive, Mean Strategy Framework Directive, it's a good political case for actually taking things forward, and it still is a good primary use case and helps us keep very focused at this critical implementation stage of Inspire. But Inspire does offer a far greater value to this emerging IoT community. So these communities, they need the established rich data models to underpin the services that they are developing. Most IT communities have not heard of Inspire. So when we're looking at the cost benefit of what Inspire is doing, we need to get this engagement so do we make sure that this can actually happen. So the two things I want to take away from this presentation. One, don't think too narrowly about what Inspire can actually do. There's lots of stuff here which we don't actually know that Inspire can actually drive at this moment. The IoT community is one of them. Two, engage more with this community. Expose ourselves more, speak more at their conferences so they can actually start to use it and take benefit from it. Thank you very much.
Thank you. Thank you, Keiran, for going very straight to the point. It was very interesting. I think I've learned really a lot from all these presentations that have given us an idea of what Inspire can do in different domains, in the innovative systems like Internet of Things, cloud, with the use of standards, and also excellent application in the railway domain. Do you have any question for Keiran?
I know everyone wants to get to the plenary and find out where the next conference is going to be held.
Ah, yes, but this will be in 25 minutes, so we have still 5 minutes. So you can do some questions, you can make questions if you like. No, if you don't have... Okay, thank you. Yes?
Thank you. Keiran, your last point that Inspire, well, I would say the geospatial community should get involved more with the IoT people. Do they understand us? Do they, you know, because we do this as well, but it's the mindset is, what is your experience with this? Okay.
I just heard the word mindset, and I think that probably summarizes part of the answer. Certainly, the community, I think my experience working with the IT community, particularly in the context of this standard, is they see that something like Inspire needs to happen, but it's kind of an over there problem. It's not sort of like, it's a deeper thing that they'd have to engage with, and they'd rather just keep the boundaries around the sort of like the lighter weight problem that they're looking at. The IoT conferences that you go to, they are riddled with those two main areas. One is on the actual comms aspect of how you actually have an open communication infrastructure around a plethora of devices. And there seems to be a few turf wars being fought out between a lot of the major telecoms providers about the best way of actually doing that. Then there's also the security aspect around that as well, about how you embed security into that protocol. And all of a sudden, your lightweight protocol becomes quite heavy. There's a lot of focus in that area. But there's a little bit, you know, my personal view here, there's a bit of a sort of a head in the sand here about understanding what's actually needed in terms of having these richer semantics. Just because you can go out, yeah, you can discover something and you can get some values that can then be embedded into a service, doesn't give you actually crucial things that enable citizens to be able to sort of like trust the service, rely on the service, or that service to be consistent sort of like over time. I feel it's a little bit like sort of like the citizen science debate. You know, if you have enough of it, then the truth comes out sooner or later. I don't think in the IoT space we can adopt that type of approach. If we are being truly interconnected and people are making decisions about when vehicles stop at traffic lights or when vehicles actually turn left, or whether you actually regulate how a car is behaving to change its emissions profile, then that becomes a whole trusted public service, and you need to have a much more traceable and transparent workflow. I think that's a problem that the IoT community think that's the next thing we need to look at, and that's why I think it's important that we start to engage now to break down this isn't important to us sort of mentality that exists. I don't think there's anything wrong with that, it's just a case of they're focused on their particular problems at this time.
Thank you. Someone else? Thank you, Athina, for your question. And with that, then I will thank Keiran for his excellent presentation, and you're free to join the plenary session then. Thank you for coming, everyone.